All right, here we go. This is the second part of projectile motion at some angle, right, with some sort of velocity or maybe force. Because right now, pardon me, we're talking about velocity. The first thing I have to do, because there are a lot of things I want to find out. I want to find out how long, this one is just, how long is the object in the air? And how high does it go? How high? What the heck, we'll do how far as well. And I'll do that at the end. I'll grab a calculator and we'll do that. Here we go. I have an object. It's fired at 65 meters a second at 35 degrees. I want to find the two components of velocity. So I use these formulas up here. The magnitude, right? The magnitude of the hypotenuse times the cosine of 35 gives me my x velocity, my velocity horizontal. And that ends up being 53 2/10 meters a second. Then I do the same thing, but I use the sine of 35 to find out that this is 37 3/10 meters a second, rounded to the nearest tenth. The next thing I want to find out is how long it takes to go all the way up and all the way down, right? And this is where things get a little bit wonky for some people. We figure vertical motion and horizontal motion differently. We keep them separate. So if we want to know how long it took, we need to know how long it took to go up to the highest height and come all the way down. So we're going to talk about the vertical velocities. Now, an object, when it goes up in the air, we figured its initial vertical velocity is 37 3/10 meters a second. It goes to the top, it slows down vertically, it stops, and then continues and then starts to come down and accelerates downward. Now, barring any air resistance whatsoever, we're not allowed to worry about air resistance in this type of physics class, because this is an algebraic physics class. We know that just before it hits the ground, its vertical velocity is exactly the same magnitude, but in the opposite direction. So I'll write here, VIY is 37 3/10 meters a second. V final in the y direction is negative 37 3/10 meters a second. Why is that important? Well, I'm going to go ahead and do the math over here. I've reconfigured that first kinematic equation to solve for time. Remember, it's VF equals VY plus AT. Well, I reconfigured it to find T, and I'm going to put everything I know in here, and it's going to be negative, the final, negative 37.3 meters a second minus the initial, which is 37.3 meters a second. So I get negative 74.6 meters a second. And I'm going to divide by gravity, which is negative 9.8 meters a second squared. And so meters a second divided by meters a second squared leaves me with seconds. And that value is actually 7 6/10 seconds. Now, later on, I'm going to have to find out how high. Well, how high means how high is it at its peak? Well, at its peak, that's halfway through its flight. So you can either just take half of this or change the vertical velocity to 0, because its vertical velocity, when it gets to its max height, is 0. It stops and then starts to accelerate downward. So you can either cut it in half or you can do the math that goes with it, which is just 0 meters a second minus 37 3/10 meters a second divided by negative 9.8 meters a second squared. And guess what? You do come up with that 3.8 seconds. Trust me, that's how it worked. All right. The next thing is we found out how long. Now we want to know how high this sucker went up. Well, we're going to use that third kinematic equation, but it starts from the ground. So it's being launched from the ground, so we don't have any initial displacement, so we get rid of xi. Now we're going to use the initial velocity vertical times the time plus 1/2 times gravity, negative 9.8 meters a second squared, times the time squared, right? But at max height, remember, this is the time we're going to use. So you'll see I use 3.8 seconds and 3.8 seconds. So it's something you're just going to have to remember. And usually I put a little hint on a test for you so you don't forget that. When you do this math, you put all these numbers in, what you end up with is 70.98 meters or 71 meters. So how high? It goes about 71 meters in the air. Pretty high, right? And last but certainly not least, we want to know how far. Well, how far, that's an easy one. X in the x direction is equal to the velocity in the x direction times the total amount of time, and that would be 53 2/10 meters a second. 53 2/10 meters a second times the total amount of time, which is 7 6/10 seconds. And seconds will cancel with seconds. We'll get meters out of here. Let me run over here, quickly turn on this calculator and do 53 2/10 times 7 6/10. And it lands a pretty far distance away, about 400, just about 404 meters, 404 3/10 meters away. Right, so that's how far away it lands. 404 3/10 meters away. And that's it. Now, you see, there is a lot to figure. There is a lot to remember. But if you understand parabolic flight, if you understand that it starts here, goes up here, it comes back down here, and its max height is midway through the flight, you're gonna be getting there, and things are gonna be moving along a little bit more smoothly. We'll keep doing this because this is important stuff. This is the stuff that turns you into a guy who understands physics, okay? So we'll do a little bit more of this. We'll try something a little bit different, but we'll keep doing this. Just look at this problem and be ready to go tomorrow. Thank you so much for your time, and I'll see you tomorrow.